Hi everyone, this is lesson 5.6, Rates of Change in Relation Inequalities. As mentioned in last class, rational inequalities are P of x over Q of x. Due to the fact that they're not continuous, thus there are certain parts where the slope cannot be determined, and that's at the vertical asymptote. For example, if you look at the diagram below, at x equals to 1, the slope cannot be determined because there's a vertical asymptote. Now let's take a look at example 1 from your learning resources. Determine revenue of a toy store when 1,500 boxes of dolls are sold when it is the greatest and the least. The demand for the boxes of dolls can be represented by the equation P of x equals to 5 over 2 plus x. Find the average rate of change when 1.5 boxes of dolls are sold. So we map out our plan, and first step, we have to find the rational inequality equation, the algebraic expression. So let's let x be the number of boxes sold. We have the total revenue equals to P of x times x. P of x we determined from the original question. That's 5 over 2 plus x times x. That's going to be 5x over 2 plus x. Next, what we do is we try to find intervals that's around x equals to 1.5 and see what we get for the average rate of change. And then we try to decrease these intervals to as little as possible and see what happens to the rate of change. Now you can see that as the intervals decrease more and more, the average rate of change gets closer and closer to the number 0.816. So we can conclude that the average rate of change approaches 0.816. In conclusion, the marginal when 1,500 boxes of dolls are sold are approximately $0.82 per boxes of dolls. Now let's take a look at example 2 from your learning resources. It asks us to estimate the slope of the tangent of the graph of f of x equals to x over x plus 3 at the point where x equals to negative 5. Recall the average rate of change equals to f of a plus h minus f of a divided by h. We have to find the number of f of a plus h such that f of a plus h is almost the same as f of a. So h has to be extremely small. In this case, let h equals to 0.001. That's a pretty small number. So let's say average rate of change equals to f of negative 5, that's f of a, plus 0.001 minus f of a, which is f of negative 5, divided by h is 0.001. If we work that all out, that's going to be 0.754. Therefore, the slope of tangent at x equals to negative 5 is 0.75. So as a continuous of last question, why can't there not be a tangent line where x equals to negative 3? Well, the value of negative 3 is not in the domain because the denominator cannot be equal to 0. So no tangent line is possible there because of vertical asymptote at x equals to negative 3. So that's the end of this lecture. Thank you for watching, and remember to do your assignments. I'll see you guys next time.